Continuation of lecture number 2.7. The second factor which affects the stopping distance is speed of vehicle. The speed of vehicle is higher, then the required stopping distance will be more. We see in the accident analysis, the vehicles are running at higher speed and their required stopping distance is more, but the obstacle is very near. They are unable to control the vehicle and the accident has occurred. So that's why it is recommended to run the vehicle at a design speed or lesser than the design speed for safe movement of vehicles. Here it is directly proportional to the speed. And the third is efficiency of brakes. We can say efficiency of brakes is said 100% if the wheels are fully locked, preventing them from rotating. But it is not good. This is because the 100% locking of wheels will result in skidding, and which is normally undesirable, and that is very dangerous also. That's why the brake forces should not be more than the force between wheel and tires. Present day technologies, earlier days, if you apply a brake, there is to skid distance we used to consider that was more. If a vehicle is running at higher speed, skid distance is more. If the vehicle is running at lesser speed, skid distance required will be less. But present day technology has developed EBD, ABS, and brakes like disc brakes are coming. And because of that technology, we are not able to stop the vehicle instantly, and that is not good also, because the vehicle has acquired certain momentum and because of it which is moving. And yes, definitely we have reduced the we have increased the safety factors, like the rolling of vehicle, or vehicle is not coming out of the road, so its distance we have reduced it. So that's good, a braking efficiency, but we cannot make it as 100% because that is very much dangerous. Next is frictional resistance between road and tires. This it depends on skid resistance, or coefficient of friction small f between the road surface and the type uh, tires of the vehicles. And this coefficient of friction is directly proportional to the type of the road surface, whether it is a smooth surface, new road, old road with the potholes, or it is a rough surface, is there bituminous road, or a cement concrete road. And the type condition of the tires also, whether it's a new tires are there, good grip is there, or it's a very old tires, and there is no grip because of there is a possibility of skid. IRC recommends specified this coefficient of friction between 0.35 to 0.4, and depends on the speed. Higher the speed, lesser is the coefficient of friction, and lesser is the speed, higher will be the coefficient of friction. And this F value we are using in calculation of stopping side distance or overtaking side distances. They have given the separate table for various speeds of vehicles. And the next the factor is gradient of the road. So as we know, for if the vehicle is moving on rising or up gradient, because of the gravitational force and the distance required will be less. But if it is the vehicle is moving on a down gradient, because of acquired momentum, the distance required will be more. Stopping distance required will be more. So this gradient is mentioned in terms of percentage, n%. So if it is up gradient, we are in the calculation part we are taking plus n%, and if it is down gradient, minus n% will be considering. In the next presentation I will be discussing the problems on SSD, including gradients.